Today in this video we will get to know about the relational data model, relations database schema and update operations. For the subject 21 CS 53 database management system 5th sem. Let us first go through the course outline. The first topic will be relational model concepts. Second concept will be relational model constraint and relational database schema. And the last topic will be update operation and dealing with constraint violations. Relational model concepts. The relational model of data is based on the concept of relations. A relation is a mathematical concept based on the idea of sets. The strength of the relational approach of data management comes from the formal foundation provided by the theory of relations. We review the essentials of the relational approach in this chapter. Relational model concepts. The model was first proposed by Dr. E.F. Codd of IBM in 1970 in the following paper, The Relational Model for Large Shared Data Banks Communication of the ACM, June 1970. The above paper caused a major revolution in the field of database management and earned Ted Codd the covered ACM during the award. Informal definition. Relational. A tuple of values. A relation may be thought as a set of rows. A relation may alternatively be thought of as a set of columns. Each row represents a fact that corresponds to a real-world entity of relationship. Each column typically is called a column name or column header or attribute name. Formal definition. A relation may be defined in multiple ways. The schema of relation A1, A2 and so on up to AN. A relation schema is defined over attributes A1, A2 and so on up to AN. For example, customer ID, customer name, address, phone, etc. Tuple. A tuple is an ordered set of values. Each value is derived from an appropriate domain. Each row in the customer table may be referred to as a tuple in the table and will consist of 4 values. A relation may be regarded as a set of tuples. Columns in table are also called attributes in the relation. A domain. A domain has logical definition. For example, USA_phone number are the set of 10-digit phone number valid in the US. A domain may have a data type or a format definition defined for it. An attribute designates the role played by the domain. Example, the domain data may be used to define attributes, invoice date and payment date. A relation is formed over the Cartesian product of sets. Each set has values from a domain. That domain is used in a specific role which is conveyed by the attribute name. Formally given R, relation A1, A2 and so on up to AN, relation R is a subset of domain A1. Formal definition, let S1 be equal to 0, 1, F2 equal to A, B, C. Let R be a subset of S1 cross F2. Then for example, relation of R is one possible state or population of entity. Definition summary. In formal terms and formal terms. Table relation. column, attributes and domain. For rows, tuple, values in a common column, domain, table definition, schema of a relation, populated table, extension. Let us go through the given example here. Relation name is student. Tuples are the name, SSN, home, phone number, address, office phone, age and GPA of that particular name. And attributes are name, SSN, home phone, address, office phone, age and GPA. Characteristics of relation. Ordering of tuple in a relation. The tuple are not considered to be ordered, even though they appear to be in the tabular column. Values in a tuple. All values are considered atomic. A special null value is used to represent values that are unknown or inapplicable to certain tuples. Notation. We refer to compound values of a tuple T by T A of I is equal to V of I. The value of attribute A of I for tuple T. Similarly, tuple T A of U, A of V, and so on up to AW refers to the subtuple of T containing the values of attributes AU, AV, and so on up to AW respectively. Characteristics of relation. For this tuple, relation name is student, attributes are name, SSN, home phone, address, office phone, age and GPA. For tuple Barbara Benson, that second tuple, SSN is 53369, home phone, address, office phone, age and GPA. Relational integrity constraint. Constraints are conditions that must hold all valid relation instances. There are three main types of constraint: key constraint, entity integrity constraints, referential integrity constraints. Key constraints. Superkey of R, a set of attributes S of K of R such that no two tuples in any valid relation instance R will be the same value of Sk. That is, for any distinct tuple T1 and T2 in R relation R, tuple T1 Sk is not equal to tuple 2 of Sk. Superkey. Example: the car relation schema given here. Key constraint. The car relations with two candidate keys, license number and engine serial number. Let us go through the given relation. Entity integrity. Relational database schema, a set S of relation schema that belong to the same database S is the name of the database. S is equal to relation R1, relation R2, and so on up to relation R1. Entity integrity. The primary key attributes of each relation schema R in S cannot have null values in tuple R. Referential integrity. A constraint involving two relations. The previous constraint involves a single relation used to specify a relation among tuples in two relations, the referencing relation and the reference relation. A referential integrity constraint can be displayed in a relation database schema as a directed arc from the relation R1 Fk to relation R2. Referential integrity constraint. Statement of the constraint. The value in the foreign key column or column foreign key of the referencing relation R1 can be either a value of an existing primary key value and the corresponding primary key pk in the reference relation R2, or a null in the case 2 for other types of constraint. Semantic integrity constraint based on the application semantic and cannot be expressed by the model per se. SQL 99 allows triggers and assertion to allow for some of these. Schema diagram for company relation database schema. The primary key are underlined. For employee, first name, min, ID, L name, SSN, birth date, address, sex, salary, suspense, super SSN, DN. The underlined are primary keys such as D number, P number, ESSN department name. We have another example of company schema. One possible relation database state corresponds to the company schema. Let us now go through the referential integrity constraint displayed on the company relational database schema diagram. The primary keys are SSN, D number location, and D number for department location, P number for project, and ESSN P number for work on, and ESSN department name for department. Update operation on relations. Insert a tuple, delete a tuple, and modify a tuple. Integrity constraints should not be violated by the update operation. Several update operations may have to be grouped together. Updates may propagate to cause other updates automatically. This may be necessary to maintain integrity constraints. Update operations on relation. In case of integrity violation, several actions can be taken. Cancel the operation, perform an operation, but inform the user violation. Trigger additional updates for the violation is corrected. Cascade options, set null option. Execute a user specified error correction routine. So this is the example. You can try it on your own. Consider the following relation for the database that keeps tracks of the student enrollment in courses and the books adopted for each course. For student, primary key are SSN, and other keys attributes are name, major, and birth date. For course number, course name, department. For enroll, SSN, course name, quarter, grade. Book adoption, course number, quarter. Book ISBN. For text, book ISBN, book title, publisher, author. Draw a relational schema diagram specifying the foreign keys for the schema. This is all for today.